The nice thing about this one is that you've already got 0 on one side and everything is written with one rational term. So that means I need to find two things. I need to find where the denominator equals 0 and where the numerator equals 0. So the denominator equals 0, that's not too bad. That's just 4x equals 1 or x equals 1/4. Okay, not so bad. Numerator equals 0 is more of a problem. 20x squared plus 21x plus 4 equals 0. Personally, I was horrible at factoring these kinds of problems when I was a student in Math 1150 at OCC. I was absolutely horrible. But there is relief on the way. Now, you could use the quadratic formula. There's nothing wrong with that. But let me show you something that's actually kind of cool. So I sent you that Desmos link and I posted the QR code. Here's another quick look at the QR code if you want it. But it's going to be kind of helpful here for you. Let me go to that link here. And I'm going to shut off this graph here and turn on this one. This is just the numerator, right? That's just y equals the numerator. If I wanted to find where this equals 0, it's the same thing as finding the x-intercepts of this graph. In other words, setting y equal to 0. Now here's the cool thing about Desmos. It'll tell you that. It's like, oh, you want to know where it's 0? Just click on me. Oh, it's 0 here, and negative 0.25 and negative 0.8. Let's take note of those two things. Negative 0.8 and negative 0.25. Now, kind of a cool thing here that you can do at Desmos is if you just type in those values and you're like, well, that looks familiar, but I don't really recognize what it is. You hit this button, it'll turn it into a fraction for you. Oh, yeah, that's right, negative 4/5. How about negative 0.25? What's that as a fraction?
Negative 1/4.
Negative 1/4. Perfect. So let's write both of those down here for myself. So x equals negative 4/5 and x equals negative 1/4. Now watch what I'm going to do with this. In each of these, I'm going to get rid of the fractions. So how would I get rid of the fractions in this one? What would I multiply both sides by? 5. Nice. So that's going to give me, well, 5 times x equals, what's going to happen when I multiply this by 5? What's going to happen with those 5s? Cancels out. So it leaves me with 5x equals negative 4, right? Let's move that to the other side and I get 5x minus, or 5x plus 4 equals 0. I'm going to leave it there for the moment. Now, how about this one over here? What would I multiply both sides by here so I get rid of the fractions? 4. So I'll multiply that by 4. So 4 times that gives me, well, Melanie, what equation would I get when I multiply this by 4 on both sides?
Cancels out. X equals negative 1.
4x equals negative 1. Great. Now, let's move this to the other side. When I move that to the other side, what equation do I get here? 4x plus 1 equals 0. Now here's the cool thing. And it's not necessarily something that we need for this problem, but it's kind of a nice little trick here. Those two binomials, that's how this factors. This factors into 5x plus 4 times 4x plus 1. Wow, that's kind of cool. We kind of reverse engineered how this factors by solving the equation. So that's kind of helpful when you need it. In fact, literally speaking, because I was so bad at this, factoring these things, I used to use the quadratic formula to get these factors, to get these roots, and then I'd reverse engineer how it factored from there. You guys can just look at it on Desmos. That's kind of nice. In any case, let's keep track of all the things we've got here. we've got roots at -4/5, -1/4, and +1/4. I need to find test points in each of these intervals. Now it's helpful that Desmos showed us that that was -0.8 and -0.25, etc. And this is of course 0.25 because I need test points in these intervals. Now before we forget, let's write down what the intervals are because it's easy to make a mistake and confuse test points with intervals. So this is going to be -∞ to -4/5, -4/5 to -1/4, -1/4 to +1/4, and 1/4 to infinity. Okay. Can you understand now why I put these decimal values down? I need to find points in between here. So, Devin, what's a point to the left of this one?
0.9. Or
All right. -0.9. Great. Hunter, how about something between these two?
-0.5.
Sure, -0.5. And my marker is dying here. -0.5. Good. Melanie, how about something else here? I need something between these two. Well, I know this goes from negative to positive, so if it does that, it goes through what number? What's the dividing line between negative and positive?
I don't know.
0. So, and then I need one more here, over here. What would be a good test point to the right here? What to who? 0.9? Good. I mean, you're free to use integer numbers too. I mean, like 1 or 2. I mean, but that's fine. Now, to test these, you're going to test these in this inequality right here. So let's see about testing those. Now, for your convenience, what I did on that little Desmos link that I gave you is I created this function right here. And I actually created a little table. Now, what's the information that I'm looking for? What do I need to find out when I test points in this table? It doesn't matter necessarily that if I type in -0.9, I get this number. There's something else that's of interest to me in this. What is the information I need to get out of this? Caden? What information do I need when I put this number in the table? Some help?
It's positive.
Yeah, if it's just positive or negative, that's all I'm looking for. And we're going to keep on going through with all the rest of these. So -0.5, and then 0, and then 0.9. So let's see. It goes negative, positive, negative, positive. That's typical of what you're going to get. It's not always guaranteed to alternate in sign, but usually does. So when it does, you feel more confident. So this was negative, positive, negative, positive. Which intervals do I want? Look back at the original problem. Do I want the positive intervals or do I want the negative intervals? Negative, because I want to know where this is less than or equal to 0. So that means I want this one and this one. Now, because it's a less than or equal to 0, I've got to consider the endpoints. And the job of considering the endpoints gets a little bit easier because we actually took the time to type in a function like this. So let's test the endpoints. For instance, I'll test -4 divided by 5. That gives me a 0. Well, that'll work. All right, that works. Actually, I don't need to graph these, so I'll shut that off. 0 is less than or equal to 0. I can use that point. How about the next endpoint? -1/4. All right, -1 divided by 4, that gives me a 0. I can also use that endpoint. What about +1/4? Oh, undefined. Why is it undefined? I did everything else right. What did I do wrong? Well, the answer is you didn't do anything wrong. The answer goes back to the fact that at x = 1/4, this is 0. And so effectively you're dividing something by 0, and you can't divide by 0. It just doesn't work. So you can't use that one. So if I can't use that one, that means it gets a parenthesis. How about these other two? -4/5 and -1/4. Well, those should get brackets. Your final answer should look like this: -∞ to -4/5, bracket, and then union. We can use the -1/4, -1/4 to +1/4. +1/4 gets a parenthesis. I can't use that because it puts a 0 in the denominator. But I can use these other ones. There's nothing wrong with either of those. So, comments or questions on that one? All right. Try some of these before you leave because they're challenging. And if you need some help, I'll be here.